Hello, I'm that James guy, and today I'm going to try and answer the question, is an EV conversion worth it? Many of you probably don't even know what that would be, an EV conversion. Well, that's turning a gas-powered ICE, internal combustion engine car into an electric car. And I did this. I had a 1992 Mazda MX-3 Presidia, I think they're called. And I got this thing super cheap, and I wound up turning it into an electric car. Now, this is something that isn't very common, never really was, but it was a little more common before mainstream electric cars started hitting the market. But this was actually a thing. There was a little bit of a grassroots following. People converted cars into electric cars. So what I'm going to talk about today, I'm going to talk about four things. We're going to break this down into four segments. Inspiration. My inspiration for doing the project. Number two was goals and design. You had to have a goal and a design, I guess, for any project, not just an electric car project. The third one, we're going to walk through how I did it. I do have some old footage of how I actually, mostly pictures, but there is some video footage as well on how I tackled the project and got through it. And then finally, we're going to ask the question, number four, is it worth it to convert a gas car into an electric car? So number one, inspiration. Now you'll have to understand that there were no mainstream electric cars. So I did this back in 2012. I bought this car for $400. It was a beater, it was dented. It drove okay other than a major exhaust leak. I drove it around for a couple weeks just to make sure the car was fine. But back then, there was a few people doing it. So a couple examples, we had a guy named Darren. He had a car called the Forkin Swift. And what he did is he took a Suzuki Swift and he bought a giant electric forklift and basically used the guts from this forklift to make this electric car, to convert it. And actually the goal was super cheap, ultra cheap car. And he wound up selling a lot of the parts for scrap from the forklift. And he actually, I think, kind of came out like he basically made this car for free. Another guy back then, his name was Ben Nelson. He had a little Geo Metro, I believe. He made one. And a lot of these guys were documenting this stuff. There was a forum back then called DIYelectriccar.com. I think it actually exists still. Another good site that I was involved with a little bit was ecomodder.com. And ecomodder isn't just EVs. A lot of it is just basically guys modifying their cars for fuel economy instead of performance. I documented my whole project on ecomodder.com in the forums there. I'll actually put a link below so that you can see all 40 pages of reading pleasure with photos and everything. That's where I documented it. And so these guys basically, they would go with a direct current motor instead of, all your modern electric cars. It's all alternating current, AC power. Many advantages to AC, but it was really expensive back then. And with some forklift parts, junkyard parts, most of that was direct current, so you could wind up with a cheap motor and you could put it together and make your project for really cheap. So yeah, that was my inspiration. A couple of these guys were doing it. I actually got a hold of them. They were really helpful, and they kind of helped me, plan and build this thing and turn it into something that I actually could use for a couple of years, getting to work and back. So number two, design and goals. I wanted a cheap car. I wanted to basically a project to do where I could make this cheap electric car, put it all together, and just get 6 miles to work and back. That's it. That's all I had to do was 6 miles. I think every once in a while I'd go a little further, which was like a 12-mile, 13-mile round trip, but that was my goal. And I had access to a bunch of free battery cores. I work at a truck dealership, so often when we change the sets of 4 Group 30 batteries, usually there's 1 or 2 that are still okay, but you always do them as a set. So I started collecting parts. I started collecting batteries from the battery core shed, and I would charge them up and I would test them, load test them, and I found a group of a bunch of these batteries that wound up working, and they could get me to work and back. I wanted something, it was going to be direct current. I had access. I found a cheap motor on eBay, but it ended up, the guy kind of ripped me off. He sold me something that it wasn't. Initially I wanted a series wound DC motor. That's what the norm is to use. Super easy to control. I had purchased a golf cart controller, basically a souped up golf cart controller. Basically you could use it if you wanted to, you know, make your golf cart super fast. It was rated up to 72 volts, which is way higher than most golf carts, but it was still very cheap. I think you could do 450 amps. So when you do the math, 450 times 72 volts, you know, it winds up being around 30 horsepower. So just to kind of give you what kind of performance I could do. My goal was I wanted to be able to do 70 kilometers an hour, which is about 45 miles an hour. That's the speed limit. The speed limit's 60 where I used to commute. And that was my goal. If I could get up to speed, if I could not hold traffic up, and if I could do this on a budget, I would be happy. And so that was it. I started collecting stuff. This DC motor that I was talking about, it showed up on my doorstep, and when I put power to it, it ended up being a separately excited motor, which is not ideal. They're a little bit more complicated to control. So if you take a series wound motor, basically power goes in the field windings, and after it's done, it goes into the armature, through the brushes, back out the brushes, and back out to the controller. So you have two big posts on the motor, and you control current basically on one wire. And that's how most golf carts worked back then, older golf carts. Well, this arrived and it was a SEPX motor, separately excited, so you need to control the field windings separately with one controller and the armature separately with another controller. SEPX actually kind of has an advantage. If you control it properly, you can actually reverse the direction of the motor. You can even do regen braking. You can't do that with a series wound motor. If you take a series wound motor, and an example would be a starter motor on an engine on your car, if you reverse the polarity of it, it's still going to spin in the same direction because you're reversing the polarity of the field windings, but you're also reversing the polarity of the armature windings, so it's still going to spin in the same direction. Anyway, I kind of walked through that, I kind of figured out a few things, and I got it to work for me. So number 3 was building it. I collected all these parts, and it was actually on the day my youngest daughter was born, and I took the week off work, and I decided, well, let's just rip the engine out of the Mazda. Let's start putting this thing together. So the first step was getting the engine out, getting the transmission and the engine separated. Of course, you have to, if you want to make it simple anyway, you have to use a 5-speed manual or manual transmission. And I decided to go with no clutch. An electric motor doesn't have a lot of inertia, so you don't have to really worry about shifting too much. The synchros in the manual transmission actually do a pretty good job, even if you don't have a clutch. So basically I took the center hub with the splines that fit on the input shaft, the center hub of the clutch, and I mated it to the shaft of the motor and made an adapter plate, and hooked the whole thing up together, and it worked. The thing up and worked pretty good. And at first, because I had this separately excited motor, all I did was feed the field windings 12 volts, then I tried 24 volts, and I think I had a switch at some point right on the gear shift where I would switch between 24 volts and 48 volts. So the more voltage you gave it and the more current you gave the field windings, the more torque it would have, but then it wouldn't rev very high, so then you would switch it on the go. I used a relay to switch between the two voltages, and I tapped the middle of my battery pack to kind of steal either 24 or 48 volts. And it ended up, once I got going, then I would flick this switch and it would lower the field windings down to 24 volts and give me more speed. Okay, this is my commute to work in my homemade electric car.
see my system voltage. I'm basically coasting right now because this is the downhill part to work. Battery pack right now, you can see showing battery current coming out of the rear pack.
After a while I decided I would try and control the field windings a little more carefully, so I bought a second controller that was, I think, a 50 or 60 volt controller by a company called Kelly. And what I did, and it was a little bit complicated, but I measured the current going into the armature windings through a Hall effect current sensor, and what it would do was send a kind of a feedback 0 to 5 volt reference into the throttle of the field winding controller. So if I put my foot into it and it put a whole bunch of current into the armature windings, the field winding controller would respond because it would suddenly see current as a throttle input, and it would put current into the field windings. And it was kind of weird. It would get into this weird kind of an oscillation, because what happens as soon as you increase your field current, it is more difficult for the armature current to go in because of back EMF. It's a motor thing. Look into back EMF, back electromotive force. And so what it would do is as soon as you would give it field windings, the current would slow down on the armature, and then the current sensor would go down, so then the field winding current would go down, and then it would kind of like, it would keep increasing and decreasing. But I was able to get around that. There was actually a buffer built into the software of that field winding controller where I could actually kind of create a bit of a delay, a little bit of a buffer, and it actually sorted that out. I drove it to work for quite a while, about a year this way, and it worked out pretty good. On to the batteries. So these batteries were actually out of Peterbilt trucks. PACCAR sells a dual purpose battery, which means it's a cranking battery, but it can actually deep cycle a little bit, you know, to run microwaves and accessories in big trucks, in the sleeper. But once you draw like 300 amps out of them and really deep cycle them down to like, you know, 11 volts, 10.5 volts, they don't like it. They died fast. So I had to set up this kind of way I could monitor each pair of batteries, and at 72 volts I ended up having 12 traction batteries. We call them traction batteries back then. And so they would be two 12 volt batteries in parallel, and then each set of parallel 12 volt pairs were in series. So I had 6 of these pairs all in series, which added up to 72 volts. For chargers, I did individual chargers. It was such a mishmash of different style of batteries. If you would try to bulk charge them at 72 volts, which I did try, I did buy a 72 volt charger, they would go so far out of balance. Some batteries would shoot way over where they're supposed to, some wouldn't get charged at all. So I wound up, at first I had 6 really cheap batteries or battery chargers from Canadian Tire. They worked okay, but they were just really inefficient, old school transformer style chargers. I ended up going with some solid state, really nice chargers. I think I bought them on eBay, 6 of them, all through a whole bunch of splitters and stuff to a 110 volt plug where my gas cap used to be. Kind of looked like the Griswold family Christmas, lighting up all the lights on the roof, but it worked. And that's how I charged it. And I wound up, these batteries just couldn't handle it. I had this little device set up so that I could monitor these pairs of batteries and identify which ones were dying on me really, really quickly. And yeah, eventually I thought, you know what, I'm running out of batteries in the battery shed. I think I have to bite the bullet and I have to buy some batteries. So through work, I was able to buy a whole bunch of new AGM absorbed glass mat, deep cycle, you know, they're not gel batteries. People get confused between gel and AGM. AGM still has the plates like normal. They don't have a gel. They have more of a solid electrolyte, but they're able to handle crazy amounts of deep cycling. So that's what I bought. You know, it cost quite a bit of money, but I got them at cost through work. And man, after that, the thing performed very well. After a period of time, I got talking with Darren, who You know, he had made the fork and swift early on, and he actually had a spare motor, a series wound motor that he had used one of these in his car. It was actually, the forklift he used to make his electric car was so ginormous that the motor on it was like 400 pounds, just this huge massive thing. But it did have two motors that were 8 inches in diameter, maybe a little longer than a foot long, and about 80 pounds, that basically ran the hydraulics of this forklift. And he had used one of them. He had this other one sitting in his garage, and he said basically, hey, you want it, just have to pay the shipping. And so kind of, I think it was over one of the winters where I had this car, I basically took it all apart, I got this motor, and I cleaned it all up. The problem was it spun the wrong way, and like I said, with a series wound DC motor, if you reverse the polarity on it, it's still going to spin the same way. So I took the whole thing apart and I basically changed the internal polarity and also the timing. Did you know that DC motors are actually timed? The way the armature kind of goes past the brushes means whatever rings are touching the brushes at the same time, those are the ones that get the power, and it's timed so that the magnetic force is always pulling towards the field winding magnets. They're always advanced by between 5 to 10 degrees. So I had to reverse the internal polarity plus time it correctly so that it would be timed. It was lots of nerding out on Google. I wound up figuring it out, got it all together, and then it spun the right way. I painted it beautiful Caterpillar yellow because I had access to lots of free Caterpillar yellow paint. Put this thing all back together, and I decided, you know what? While I'm in here, why don't I make the tachometer work? So I even took the coupler, because this one had a completely different drive system. It had a standard hydraulic pump drive female splines into the motor. So, you know, my buddy Matt helped me weld up a new coupler. I put 2 tangs on it and a proximity sensor, and I basically fed a 12-volt signal into the old negative coil supply. That's how it generally, on a gas engine, how the tach worked. At least that's how they used it. The tachometer basically reads the pulsing on the ignition coil negative side, and it turns that into an RPM. And lo and behold, I had tachometer after that, which was kind of ridiculous, an electric car having a tachometer and a 5-speed gear shift. The tach, very happy with that. I think it had slightly less power. It just ran way nicer. It didn't have that oscillation like it did with the separately excited motor. My 0 to 50 kilometer per hour, which is about 30 miles an hour, was like 13.5 seconds, which basically means if I gave it like 80 or 90%, I would just nicely keep up with traffic. So it was fine. I never really held anybody up, even with a bit of a uphill drive to get home. And it worked pretty well. I did a 0 to 100 test. I think I documented that one time. It actually went 100 kilometers per hour, 62 miles an hour. Of course, probably with a little bit of speedometer error. But it did it. It took exactly 1 minute to get there, from what I remember. And it was a little scary, but it did it. Some of the interesting design things. So it's one thing to hook up an electric motor to a car and make it drive, but then you have all these other things to think about. Like, what about your power steering? Power steering. Well, this was such a small car that I wound up just removing it. Didn't really need it. It was a little hard to steer, but once you get rolling, it was fine. Brakes. You need vacuum for your brakes. So I bought a vacuum pump from a Volvo car. Lots of Volvo turbocharged cars have a vacuum pump. Actually, lots of cars nowadays have vacuum pumps because they're turbocharged. They don't have nearly the vacuum that's required to operate the vacuum brakes. And I had a big vacuum reservoir and a little switch, so as soon as it reached a certain level of vacuum in the big vacuum reservoir, then the vacuum pump would turn off. So it would just cycle as you use the brakes. I wanted a bit of feedback so I knew when the vacuum pump was operating, because you couldn't really hear it. It was actually pretty quiet. So I actually wired it into my low oil pressure light from the old engine that wasn't being used anymore. So whenever the vacuum pump turned on, my low oil pressure light would come on, just to kind of give me a bit of a feedback, so I knew everything was working properly. Kind of gives me an indication when the
when the vacuum pump turns on and off.
Accessory power. So you still need 12 volts to power up everything in the car. What I decided to do was just put a 13th battery in the car and just have it drain, run the stuff in the car. And then I had a separate small battery charger that every time I plugged my car in, it would turn on and just charge up. I probably next time would use a DC to DC converter and a much smaller battery. A, it would be lighter. B, it would charge everything to, 13.8 volts, 14 volts like a car should be at. Whereas this one would be at like low 12s. As you drove, it would go into the high 11s. Your headlights weren't quite as bright as they probably should have been. All that kind of stuff. It worked okay, but it's probably one thing I would change in the future. Heater. Another thing is the heater. How the heck do you heat your car if you have no engine coolant heating things up? What I wound up doing, there was this very convenient little ducting that went from the blower motor to the actual HVAC, kind of the control, hot, cold mode switch and all that kind of stuff. And I found a hairdryer on sale at Canadian Tire, and I just basically gutted it, and I took the heating elements and I put it in this little bit of ducting. And at 72 volts, it wasn't running quite as many volts as the wall plug, and it was direct current, not alternating current. It wasn't like it was hot coming out of there, but at least it would keep the windows nice and clear and keep the frost from forming on the outside of the car, and it actually worked pretty good. I ran it through a big huge relay that looked like a Ford starter relay from like the 1960s or something like that. It worked just fine, and I had a separate switch on the dash that I could turn it on and off, and if I needed heat, I would flip the switch on and I had heat. That's about it for extra designs. You can read more of my kind of documenting this whole thing in EcoModder, the links below. Also documented in EV Album. It's still a thing. People still document their homemade EV conversions in there. Links below. Just to there's a few more pictures and whatnot in there. You can see kind of how it all looked. So here is the wiring schematic. This is how the car kind of ended up. You can kind of see here the two packs, one in the front, one in the back, and how they are all connected in series. There's a big giant fuse at the top that was just kind of a safety, just in case something really bad happened. All of the current to the controller, even in modern day cars, goes through a big giant contactor, which is a humongous relay, just in case you have to, panic and turn the key switch off. That contactor has the ability to cut all current to the motor, and so you can safely pull over. Like I said, even brand new electric cars have stuff like that. It doesn't show the chargers, but that was just pretty much simple. Each pair of batteries was hooked up to an individual charger. Total of 6 chargers for the traction batteries, and I had an extra charger just to do the accessory 12-volt battery. One of the questions people sometimes have is insurance. What did I do about insurance? Back in the day, we had to do smog tests on our cars. We don't anymore. I guess the government figured that cars are clean enough, we don't have to anymore. All I had to do, in British Columbia at least, was go into my insurance agent, and they just changed the fuel type right on my insurance. So that got rid of having to do smog inspections, smog testing. It's kind of strange that I could just do that without without actually proving it, but that's what I did. And that brings us to number 4. Should you do an EV conversion? Is it worth it? So the short answer, no. Nowadays, it's not worth it. Back in the day, there was no mainstream EV cars. I think the Leaf had just come out. I think Tesla Model S was fairly new. It was, a few years old, out of anyone's reach as far as price. The i3 BMW, they were 50, 60 grand. Back then, it kind of made a little bit more sense. If you needed something just to hop around, run back and forth to work, it kind of made sense. But now you can go find a used Nissan Leaf with a blown out battery pack for 7 grand, 8 grand, and it's like factory made. Everything just works. There's no tinkering around with, is it going to charge today? Is it not going to charge today? You can go and buy a whole bunch of these little battery cells, Nissan Leaf battery cells on eBay for like a couple $100 each, and you can rebuild a Leaf battery pack yourself. They're really easy to do. There's not much to them. You just need something to lower the thing out of the car and take it apart. Just educate yourself so you don't kill yourself, because it's quite a bit more volts than 72 that were in my car. And if I were to do it again, I would certainly go lithium ion. Now that all these Leaf battery packs are available online, it's like it'd be super easy. They come almost, it's about the size of a sheet of paper, like 8.5 by 11 piece of regular old paper, and they're about that thick, an inch and a half. You buy like 20 of those things. You don't have to put them all in one pack. You can kind of put them wherever they have room in the car and just wire them up accordingly. It's actually pretty simple. But the main problem with a homemade EV is nobody wants to buy a homemade EV. If you're planning to keep your homemade EV for a long, long time, like forever, that's one thing. It would be kind of neat to do a little sports car, something that you would just keep forever. But I don't tend to keep cars very long. I drove my MX-3 for 2 years, 2.5 years, and then because of where the battery pack was, I had no back seat. That was the compromise I made. I didn't want a back seat. It was too small anyway. I wanted a trunk instead. And eventually my kids were getting a bit older and I had to drive them around to places, and basically I just needed to get rid of it. And I had it for sale for a long time before I finally gave up. People would come over and take a look at it, and covertly they were just trying to see how to build their own EV. They wanted to look at one, but they were jerks and wouldn't tell me. Then they would thank me and never call me back. I wound up parting it out. All of the bits and pieces that I ended up scrounging together and making my electric car, I parted it out. I think all my batteries went to some guy with a solar panel array. He wanted to, charge or power his house with solar panels, and he needed some batteries for that, which is great. Went to that. And then at the end of the day, I had a glider with no engine in it. Basically, the tow truck pulled it away, and the amount of scrap I got for it paid for the tow truck, and the car was gone. So if you spend $8,000, $10,000 on an EV, you're never going to get that out of it. Unless you drive it for 10 years and wear the thing out, then it's worth it. But otherwise, it's just not worth it. My Fiesta project that I just finished, when I had a hole through the side of the engine, one of the things I was considering was getting some Leaf parts for it and converting it. I figured I could probably do it for about $8,000 and have myself a cool little Fiesta EV. But at the end of the day, if I ever had to get rid of it, I would have been stuck with it. I would have had to part it out, spend lots of time taking it apart, and yeah, probably would have been just really annoying. I probably still would have had it. Probably still wouldn't have been done the project, and that would have been really annoying. The one thing that is worth it is it's a really fun project. So if you want to spend a bunch of money on a really fun project, it does put a big smile on your face every time you drive it. It might be worth it, but still, it might not be worth it. So that's it. I think I've covered everything I need to cover. If you have any questions, if I didn't cover anything, please ask the questions in the comments below, and I will do my best to answer them. If you found this helpful or even just mildly entertaining, please hit the like button, hit the subscribe button, and I will see you next time.